Welcome to another hacking session on RLCI. This is an experimental CI/CD system that I'm developing here, trying to practice an agile approach. So down here in the README, I have a couple of stories to possible things to move forward with, and in this session I'm going to work on this one. So right now, RLCI works like this. So it runs a predefined pipeline. At the moment, it just prints that it ran okay. So this story is about extending what this hard-coded pipeline does. And I would like that pipeline to be the pipeline for RLCI. So what should that pipeline do? Like, should integrate the branch and run the tests and stuff like that. So that's what I want to work on in this session. Also, I noted some else possible refactorings that I might want to tackle first. So let's go ahead and start the command server to run the tests in a loop. And as you can see, the first smell here, text test runner output stuff for test, went really shouldn't. So as you can see, we get two outputs here from a test run, and only the second one here is the one we care about. So the other one comes from a test case. So let's have a look at 0pi, and in the test class, I think it's this one. So this one instantiates the real thing, adds a dog test, and it runs it. And when we run the tests, something is output to the console. And in this case, we don't want it to output to the console. Perhaps we want to assert on it instead. So to fix that, one thing that we could do is to run this piece of code in a sub-process instead. So we have an example here. So let's see if we can do that. So in that case, we want to say import 0, tests equals 0.tests, and then we want to do tests doc test and doc test module, and then we want to do tests.run, something like that. And let's see what we get back. So we get nothing back, and I suspect that is because nothing is output to standard out. So instead, let's capture standard error as well. And output that, and now we can see this test one. Okay, so we're making some progress. So let's call this result, and then we can say that binary ran one test should be in result.stder, like that, and that passes. So now we have the same test, but we also assert that it prints this line. But we also want to assert the return value. So in that case, we can print the output from tests run, and say that result.stdout should equal this true 1, and then a new line. Alright, so now we have this test written using subprocess instead, so we can remove this test. And now the output from this test code is not shown. Instead we capture it and assert that it looks in a specific way, and we only see one output here. So let's see, if I want to clean this up a bit, we could write these on separate lines to make it read a bit better. Let's see, something like that, should still pass. And let's see, yeah. I run duck tests and return. I run duck tests, print result, print. I run duck test, print report to stdout, stdr, and return success number of test run. So let's assert in that order. We have the report on stdr, and we print on stdout the results of the run function, and it's true 1 in this case. Yeah, so I'm happy with that. Alright, that was the first one. The other one I would like to have a look at before continuing with the first story is this import. Start the command server again. So here we used a built-in import function, and that will actually try to import a module. So in a test here, when we create a null version, for example, yeah, this one is a good example. So if we call the doc test, if we enter something here that doesn't exist, we'll get failure, because it will try to import that stuff for real. You shouldn't really do that in a null version. But now when I'm reading this test, I'm thinking that in this particular test, we're not interested in adding a doc test. I'm not sure. Yeah, so we don't add any tests, we call run, and we still get 5 back because we have simulated that. So I think that reads better. But in this test down here, I want to say irrelevant module name and assert that that comes out down here. This is not possible because it will try to import. So one way to fix that is to use the import lib, I think it's called. Import lib is not defined. And now we can use it down here, saying self.import lib.import module. And we still get this failure. And I suspect that is because we're not passing in a fake here. So import lib null. It's funny any class. What do we need to define on it? Import module. And it does nothing. So let's also format this. All right. So now in the null version, you can call it with whatever and it still works. And no need to import stuff for real in a null version. And up here, we still test that importing works. It runs one test and we get this output. So yeah, I'm happy with that. Let's see if we can break these lines to read a bit better. Or just not that big a fan of variables, so I prefer something like this. Add test, doc test 2, yeah. Okay, so now let's move on to the actual story, the thing that will actually add some value to RLCI. Let's have a look at the test here. So what does it say? RLCI, I'm a tool to facilitate CI/CD. So I would like to first rephrase this a bit to clarify what it does. So I would like to say that I can trigger a predefined pipeline. And in this case, I would like to call it also with arguments. Maybe trigger, just to make it clear that this usage is to trigger a run of a pipeline. Let's start the command server and see what happens. So got an unexpected arguments. So let's add it here, default to empty list. And that still works. But I also want to say I fail when given other args, something like that. So if we run with no arguments, for example, I want to have it exit with 1 and perhaps std out or std error. Not sure we have that. Let's do std out as a usage trigger, something like that. So for this to work, we need to have arguments. I don't think we have that here yet. So let's steal that from the 0pi build script. So for a moment, I'm going to comment out this test. And let's head over here and we have args. So let's copy this. Stuff is going to fail. Let's paste it down here and then we can import it here. Still good, okay. And now back here we can say terminal args is none and self.args is args. If args is none, else args. Okay. And then run in test mode, we can say terminal args is args dot create null args. Is that how it works? Args create null, yes. And now we should be able to include this test again and say something if self.args.get is trigger. Actually, we can just start like that and comment out, make sure that that works. Yeah. Oops. So let's go back here, and otherwise we can do self terminal print line usage and now we get the first part right, so now we just need to exit. And that doesn't work because we need this try app run except system exit and append exit e.code. System exit. All right. So this was just to clarify that at the moment, RLCI, the only function of RLCI is to trigger a pipeline, the predefined pipeline. So just wanted to make that a bit more clear. Okay, so let's have a look at what I wrote here. The hard-coded pipeline currently does nothing, sure. We could start fleshing out this pipeline to be the pipeline that RLCI could use. The first step in that pipeline should be to integrate a branch, merge with main, and run tests and promote if passed. So the idea here is that if I made some commits to RLCI and I want to push those commits through the pipeline, the first thing we should do is to merge my changes with the main branch to make an integration, and then we should run the tests on that integrated commit, and if it passes, we should promote that. So how can we test that? So this is the test right here for the trigger. So first of all, so imagine that this is running somewhere on a server and it gets no input. We can hard code the repo, the RLCI repo, but we need to pass another argument, which is the branch to integrate, or the commit to integrate. But let's for a second assume that we can hard code that as well. I imagine that the things we want to do here, is something like, so we want to do, first we want to do git clone the RLCI repo. Then we want to do git merge with the branch. Then we want to do 0pi.build, and if that succeeds, we want to do git push something roughly like that. So this we can steal from here. And let's also assume that we can clone it to the current directory and that we start in some kind of empty directory. Let's assume that for now. And let's also assume that the branch name can be anything. Let's assume that we can hardcode the branch name, that is. So here I also want to say a message saying something like that. And I think we can specify no fast forward, force a merge commit. So something like this is what I would like to have happen when so say for example, I make a couple of changes to RLCI, I make them in a branch, I push the branch, and then I tell the CI server, hey, trigger the pipeline. So it will start by cloning the repo, merge maybe origin/branch. So we get the main branch, merge in the branch that I want to integrate, run the build script on that branch, and if that succeeds, I want to do git push to push the main branch. Yeah, and this sh here, let's give that a better name. So that should be sh for let's call it sh for shell script. And this will fail. Yeah. So what will go in here is a set of, when this right here is the pipeline. I'm thinking that this should probably be defined somewhere else, like in a different class. So these pipelines should be possible to define as a user of RLCI, but for now we're hard coding the only pipeline that the RLCI can run in here. So yeah, so let's for a moment ignore these and go back to whatever we got here, the passing tests. Now we need to implement some more infrastructure. So instead of terminal print line, we want to do something like self.sh and then run a command. We don't have sh, so let's create it. So in this case, we can make it a wrapper for like sub process, or perhaps, I don't know. Let's what should the wrapper be? I'm thinking that this should be the interface that the pipeline definitions talk to the system. So yeah, what can you do inside of a pipeline? Let's call it, let's make an abstraction. Let's call it pipeline. Sure, let's call it pipeline. And I want to be able to say pipeline .sh and then a shell script. So let's say echo hello. And I want that to return hello, something like that. So now attribute sh, let's fix that. Need to create a new pipeline and call sh. There we go. And this is going to be implemented with subprocess for now. Subprocess.run command shell true. Yeah, see what happens. Got nothing, and I think we need to do std out. Let's see. Std out pipe. Return dot std out. Okay, we're getting closer. So yeah, something like that. All right, I can run shell commands. And then null version of me runs no shell commands. So it will be pipeline create null .sh, and we should get nothing back. Has no create null. And now I need to pass a null sub process. And here we need to say and also process has no attribute run. Let's do it like that. Pipe non-type has no attribute std out. Okay, so turn null response std out. All right. Okay. And then we need to say ilog commands. So now we need to say pipeline create null pipeline.listen events and then events and then pipeline.sh echo hello events should be sh echo hello. We can solve that by saying is it emit? No. Let's see. Has no emit. First of all, we need to observable. Let's see. Notify event data. Emit notify. Observable is not defined. Let's define it a bit higher up. Okay, pipeline objects no attribute event listeners. Yeah, so we need to do init of the observable. Like that. And still nothing. I would have expected that to work. Listen. Isn't it called listen? Register event listener. Register event listener. Okay. What are we getting now? Expected nothing but got. Also, let's don't care about the result here. Yeah. Okay, so now we have our pipeline. So let's inject it here. And let's also create a null version. That works as well. Okay, so now let's take back this test. And let's see. So first, let's do self.pipeline.sh git clone and all of this. Let's see if this works. So yeah, now we get the first part right. Now we can just continue to add stuff here. Git merge, no ff. Integrate origin/branch. Getting closer, and then 0.py build, and then finally git push. So yeah, one thing that this code assumes is that the sh command will fail if the exit code is non-zero. But we haven't actually tested that. So let's go back to the pipeline and say I fail if command fails. And if we do exit 1, there should be some kind of exception or something, but there isn't. So I'm not sure exactly what to assert there, but let's say I think we can do check is true. That will raise some kind of exception. Yeah. So maybe that is fine for now. Let's do that. Yeah. So we have now verified that the pipeline will execute these commands. And we have ensured that if any of these commands fail, the whole pipeline will fail with an exception. Might wanna handle that in some other way other than an exception, but I think this is fine for now. But of course we haven't tested this pipeline. We haven't actually run these commands. So let's try to test it in the real world and see what it does. So let's first commit this. So let's see if this actually works. So now we have a couple of commits here, committed directly on the main branch. So let's do git checkout b and create the branch. And let's try to push this and see what happens. Not sure if I can do this with GitHub, but we'll see. Okay. Seems to work. So now we have a branch pushed to GitHub. And now let's create an empty directory, because this pipeline assumes that we're working in an empty directory. And now if we do run RLCI, so this will give the usage. If we run trigger, it should clone the repo here. It should integrate this branch, should run the tests, and if it works, it should push the main branch. So let's see. And if we look at this one, we can see that it created the integrate commit and pushed the main branch. Yeah. So let's go back here and remove this CI test. So if we look in this repo, it looks like this. If we fetch everything from GitHub again, we get this, and if we check out the main branch, no, that's not what I wanted. What happened here? Oh, let's do git reset hard origin main. There we go. Yeah. So now, of course, the question arises what to do with this branch. This one. Should we delete it here after we integrated it, or should that be? Is that the responsibility of the one pushing the branch? I don't know. But let's delete branch. And not really sure how you do that remotely. So let's see, git delete remote branch. Git push origin branch delete. Yeah, all right. So now we are back. So yeah, this is actually real progress. The pipeline now actually does something useful. It makes sure to integrate the changes in a branch, now hard-coded, and make sure the test passes, and if they pass, we'll push the changes to the main branch. So now all the stuff that I just did to create the empty directory and run the script and so forth could be done by 0pi. So now we can do something like 0pi integrate, for example. Integrate. So if we run this, it will create the branch, call this, push that branch to GitHub, create an empty directory, run the pipeline, trigger the pipeline, and have it do the integration. And that could be my new workflow for pushing changes, making sure that I always run the tests. So this is actually some real progress. Although there are a lot of limitations to this pipeline, this branch should maybe not be hard-coded, the Git repo should maybe not be hard-coded, I don't know, but we have worked in a small incremental step and done something useful. So there can probably be a lot more stories where we can incrementally improve this pipeline to be more and more useful once we have all the boilerplate in place. It's easier to make smaller incremental improvements. That'll be it for this session, and I'll see you in 1 week.